Alright, so let's do some more problems on here. On these two, this is pretty straightforward. You have a complementary angle theorem that says the cofunctions of complementary angles are equal to each other. Um, Sine and cosine are cofunctions, and 90 degrees minus 78 degrees, um, 12 degrees. 12 degrees and 78 degrees are complementary. Sine and cosine are cofunctions. That's all it wanted for 15. Um, Pi over 2 minus 3 pi over 10. I need to multiply this by 5 over 5 to get a common denominator of 10. And then 5 pi take away 3 pi is 2 pi. Reduce 2 pi over 10 to pi over 5. Cotangent and tangent are cofunctions. The cotangent of 3 pi over 10 is the same as the tangent of pi over 5. So let's take a look at these next ones here. You have a whole block here, about 6 or 9 problems that are in reference to this information here. They give us the sine of angle A. They give us this ratio, radical 6 over 4. So by similar triangles, if I just call the opposite leg square root of 6 and this 4, and by the Pythagorean theorem, this missing side right here is the square root of 4 squared minus the square root of 6 squared, and 4 squared is 16, and the radical goes away when you square it, and 16 minus 6 is 10. So this side is the square root of 10. For B, the cosine 5, the hypotenuse 12, and let's erase this to give me 12 squared is 144. Minus 5 squared is 25. Let's not make a silly mistake. 108 or something. Wait. 144 minus, no, not 119, yeah. Hopefully I have that. And then C, let's look at 2 as 2 over 1. The opposite leg over the adjacent leg. And by the Pythagorean theorem, the hypotenuse is the sum of the square root of the sum of squares of the legs. 2 squared plus 1 squared, hey, that's 5. So these are the 3 triangles that we're going to use in all of these. And I've already pasted the appropriate triangle to the problem. So let's go through these then. For the secant of B, I'll use triangle B. Secant is a reciprocal of cosine. Instead of radical 119 over 12, it's the hypotenuse over 119. I need to rationalize that, so I multiply top and bottom by the square root of 119, and that's what I get for that one. Here I'm using the triangle with angle C. The cotangent is the reciprocal of tangent. Tangent's opposite over adjacent. Cotangent's adjacent over opposite. So this is just 1/2. The cosine is the adjacent leg over the hypotenuse, and this is radical 10 over 4, and we can't simplify that because we can't simplify the radical 10. The cotangent is the reciprocal of tangent, so instead of opposite over adjacent, it's adjacent over opposite, and I can put this under one radical. I can simplify this because they're both even numbers. But then to rationalize this, I need to multiply by both sides by the top and bottom, not sides, by radical 3. So we have radical 15 over 3, and that's our final answer for the cotangent of A. For the secant, that's a reciprocal of cosine, and cosine is 1 over radical 5, so the secant is radical 5 over 1. And if we rationalize that, we get radical 5 over 5. For angle B here, the cosine is the adjacent over the hypotenuse. Oop, I looked up there, and I'm supposed to look right here. The sine is the opposite over the hypotenuse. Sorry about that. The tangent of B is the opposite leg over the adjacent leg, and so it's just after we found the the information on the right triangle. These you can go through there pretty quickly. The cosecant, reciprocal sine, sine's the opposite over the hypotenuse, so it's the hypotenuse over the opposite, which if you rationalize that. And for this block, let's stop here because I don't think, yeah, hope that helps.